In this lesson, we are going to cover Big Idea 3, Standard 3, and we are modeling ionic compounds with Lewis structures. So first, we need to talk about what is an ionic compound. An ionic compound is formed between a metal cation and a non-metal anion. Remember that cations are positively charged and anions are negatively charged. So ionic compounds are going to be formed between a positive ion and a negative ion. We can also say that they're formed between one metal and one non-metal. So if we look at the periodic table, the ionic compound is going to be formed with one element on the metal side and a second element on the non-metal side. Ionic compounds are formed through the formation of what's called an ionic bond. The ionic bond is going to be the bond that forms between the cation and anion. It is a bond formed between two oppositely charged ions, one positive, one negative, by the transfer of electrons. So that's going to be really important. There are different types of bonds out there. And the way that we can identify an ionic bond is that electrons are being transferred. We are going to model how these ionic bonds and how these ionic compounds form using something called a Lewis structure, or sometimes called a Lewis dot diagram. The Lewis dot diagrams show the number of valence electrons. So they only show the number of valence electrons. Since it is a Lewis dot diagram, we're going to use dots. The number of dots will be equal to the number of valence electrons. The other important thing when we are drawing Lewis dot diagrams is that you do not pair electrons until all four sides of the element symbol have one electron. Do not pair electrons until all four sides of the element symbol have one electron. So I'm going to make a little table, and we're going to do Lewis structures for every element, for one element in every period. One element in every group. And I'm just going to do LDD for Lewis dot diagram. So let's start with sodium. Sodium is in group 1. Remember last lecture we said that the number of valence electrons are equal to the group number. Sodium is in group 1. It has 1 valence electron. That means it gets 1 dot. All we have to do is draw 1 dot. It does not matter which of the 4 sides you put it on as long as you only have 1. Moving right across the periodic table, next will be magnesium. Magnesium is in group 2, 2 valence electrons. It gets 2 dots. Remember we said do not pair electrons until each of the 4 sides have at least 1 electron. So if you were to draw it like this and you paired up those 2 dots and magnesium, this one would be incorrect. Next is aluminum. Aluminum is in group 3. It has 3 valence electrons. It gets 3 dots. 1, 2, 3. They all should be unpaired. Silicon, group 4. 4 valence electrons, 4 dots. We're going to put 1 on each of the 4 sides. Phosphorus, group 5. 5 electrons. It gets 5 dots. 1, 2, 3, 4. Once all 4 sides of the element symbol have their 1 electron, now we can go back and pair up. Next would be sulfur. 1, 2, 3, 4. Fill those 4 sides first. Now I can go back and pair. 5, 6. Chlorine is in group 7. 1, 2, 3, 4. Once all 4 sides are filled, 5, 6, and 7. Group 8 would be argon. 1, 2, 3, 4, 5, 6, 7, and 8. So far the Lewis structures that we draw were just for atoms. We want to model the formation of an ionic compound. First step, draw the Lewis dot diagram for each element. Next, we are going to draw an arrow to show the transfer of electrons. Because remember we said if we're forming an ionic bond, it's forming through the transfer of electrons. The arrow always points the same way. It is going to point from the cation to the anion. Or we can say it's going to point from the metal to the nonmetal. We are going to continue adding ions until each follows the octet rule. So again, the whole reason that atoms are ionizing is because they want to follow the octet rule. They want 8 valence electrons. They will either gain or lose electrons until they have 8. Last step, your final answer. You should draw the ions in brackets with their charge. Draw the ions in brackets with their charge. Lastly, you could do like a little check, so I guess we can call this like a step 5. In your final answer, the cation or cations should have 0 dots because cations are losing their valence electrons. The anion or anions should have 8 dots. Next, this is super crucial to remember. Ionic compounds are neutral. That means the net charge should be 0. So when we add up all of our charges, the net charge should be 0. We're going to go through 3 examples. Up first, sodium plus chlorine. So step 1, draw the Lewis dot diagram for each element. Sodium is in group 1, it has 1 valence electron. Chlorine is in group 7, it has 7 valence electrons. Step 2, draw an arrow to show the transfer of electrons. It is always going to be drawn from the cation to the anion, or from the metal to the nonmetal. Let's look at what happens when sodium loses 1 electron and it transfers it to chlorine. Now, sodium doesn't have any valence electrons. It lost its 1 valence electron. Chlorine had 7. It gained 1 from sodium, so it now has 8. Let's check our answers. My cation has 0 dots. My anion has 8 dots. So we're good. Sodium lost 1 electron, so its charge would be +1. Chlorine gained 1 electron, so its charge would be -1. Last check. Is the net charge of my compound 0? +1, -1, they cancel out. So my net charge is 0. Lastly, you should be able to write the formula of your ionic compound. And the way we are going to do that is by writing the cation with the subscript X, anion subscript Y. X is going to be equal to the number of cations, Y will be equal to the number of anions. So the cation comes first, and I have 1 sodium. The anion comes second, and I have 1 chlorine. We do not need to write the 1s though. So our formula would be NaCl. Let's try another one. Let's do lithium and oxygen. So we're going to start by drawing the Lewis dot diagrams of the atoms. Next, we're going to draw our arrow to show the transfer of electrons. Lithium is the metal. Oxygen is my nonmetal. We always draw our arrow from the metal to the nonmetal. Lithium transfers its 1 valence electron to oxygen. It now has 0. Oxygen is in group 6, so oxygen starts with 6 valence electrons. It gained 1 from lithium, so now it has 7. Remember our check. We need to continue adding until my anion has 8. So how can oxygen get 8 valence electrons? Well, I could add another lithium. Now if I have a second lithium and it also loses its 1 electron, oxygen now has 8 electrons. Last step, let's put in our charge. Lithium had 1 valence electron. It lost that 1 valence electron. It has a charge of positive 1. We write ions in brackets. Green is representing the number of electrons that oxygen gained. It gained 2 electrons. Its charge would be negative 2. When we go to write the formula, cation comes first, anion comes second. That subscript X tells me the number of cations. I have 2 lithiums. Y is the number of anions. I have 1 oxygen, but again, we don't need to write the ones. Let's do one more. Magnesium and fluorine. Magnesium is in group 2. It has 2 valence electrons. Fluorine is in group 7. It has 7 valence electrons. Fluorine is the nonmetal. Magnesium is the metal. We always draw an arrow from the metal to the nonmetal. So now let's look what happens. Magnesium lost 1 electron. Fluorine gained 1 electron. So fluorine is good. It follows the octet rule. It has 8 valence electrons. But remember, the cation should have 0. Magnesium is going to want to lose that other electron. So how can magnesium lose its other electron? Well, I could add another fluorine. Again, the arrow always points from the metal to the nonmetal. All right, magnesium had 2 electrons. It lost 2 electrons. so its charge will be positive 2. The green electrons represent the number of electrons that fluorine gained. Each fluorine gained 1 electron. Go through all of your checks. Do all of the anions have 8 valence electrons? Yes. Does the cation have 0 valence electrons? Yes. Is my net charge 0? -1, -2 cancels out that positive 2. So if I add up all these charges, I will get 0. Last step is to write our formula. The cation comes first, and the cation is magnesium. I only have 1 magnesium, but I don't need to write the subscript of 1. Anion comes second, and I have 1, 2 fluorines. MgF2.